Good afternoon, everyone. Welcome to another session on IIT Hyderabad PEPS Industry Lecture Series. And today we have a eminent speaker, Dr. Mayuka Pal, who is going to give a session on overview and roadmap for autonomous asset management for electrical protection systems. I'll begin by briefly introducing the speaker, and then I'll pass over to the speaker. So Dr. Mayuka Pal is currently working with Asia Brown Boveri, that is ABB, company's Ability Innovation Center at High Tech City, Hyderabad, as R&D Principal Program Manager, leading the data science and analytics efforts globally for electrification product lines used in common digital platform. He has over 17 years of total industrial R&D work experience, of which 14 years spent in electronics product design and development for the electrical distribution business of ABB and GE in different roles as global program manager and engineering functional leader. Prior to GE, he has spent 3.5 years with OptiWave Photonics Limited, Hyderabad, as a research engineer in the design and development of optical communication systems for electrical protection devices. He has specialized in optical fiber communication systems specialization in optical fiber communication from the University of Hyderabad. He has guided 6 MTech students theses from various research institutes like NIT Warangal, NIE Mysore, IIT Hyderabad, ISI Kolkata. He has published 12 research papers of international repute in different journals and conferences and holds 3 US patents, 2 trade secrets. His current research interests include data science, physics-aware analytics for electrical protection devices, the system for autonomous asset management of electrification products, cognitive neuroscience, biomedical signal processing, econophysics using techniques like fluctuation analysis, time series analysis, multifractal and correlation study, wavelet analysis, mathematical modeling of complex systems. So as you can clearly see, today's speaker is having a very broad knowledge base and also in-depth knowledge, and as I mentioned, 17 years of industry experience in various technologies that I mentioned. So we are very lucky and we are very happy to have Dr. Mayuka Pal as our speaker today. So I would now request Dr. Pal to share his screen and his presentation and continue with his presentation.
Okay, so thank you, Dr. Pradeep. Thanks for the introduction. So, hey, good afternoon, everyone. So, I believe the post-lunch session, so I'll try to make it more interactive so that
Sure.
we discuss and not merely I speak only. So,
Sure.
yeah, so present now. Okay, it'll do like a window. Okay. Then okay, autonomous asset. Okay, let me know if you are seeing my screen, then we just get started.
Yes, we are able to see your screen.
Okay, so what's but what are you seeing? Are you seeing the presentation?
Yes, not the full screen mode, but in the presentation mode.
Oh, I see.
In the slides mode, actually, that is.
Oh, I see. Okay, let me. How do I? Okay.
Yes, now we are able to see the full screen mode. So all
Okay,
set.
much. Okay, great. So
Thank you, Dr. Over to you.
Okay, nice. So thank you so much, Dr. Pradeep, for giving the opportunity to speak to your, I think, mostly all students. So that's what I was told, to all MTech Power Electronics Power System students. So I prepared my slide accordingly so that we just talk a lot of these things, what's going on in the industry and all that. So thank you for the opportunity to discuss with the students. I always love to do that. So with this, I think I thought that, we'll discuss about the autonomous asset management and its roadmap, overview and roadmap, especially for electrical protection system. So that's where more relevant to what you guys study or work, do research and all that. So with this, I will mostly try to cover starting from a kind of I'll start from why you need asset performance management, or what I call autonomous asset management for electrical protection system. Why, first of all, we need for that? What's the requirement? Then why people are thinking of digital industrial? Uh, we know what is industrial, why digital industrial or industry 4.0 and all that. And then and all this, by the way, I'll be talking from ABB context. I mean, I currently work with ABB, so I'll give all the examples and products, details, everything related to ABB. So if there is some deviation from other industries, so do excuse me if I'm not aware of or I haven't mentioned it. And yeah, then I'll be talking about what do we mean by asset management, and especially what is autonomous asset management. Why you are talking about that autonomous, and then some case studies I'll talk about with APM and autonomous asset management from ABB, and then some future scopes, development, how we can engage. I'm closely associated with guys. I take students from IIT. Always privileged to take students for interns and all that for my various projects, research projects I do. So we'll look into that, what we do and how we engage in different activities. So with that, and by the way, I said so post launch, so don't sleep, please. I'll be keep asking questions, and I expect you guys respond. And also, please do interrupt me if you find anything that you needed more discussion. So interrupt me. Let's make it more interactive. So with
Definitely,
this,
Dr. Paul. Yeah.
yeah,
So we would also like to keep this interactive, and again request all the students also who are there to feel free to ask your doubts and questions. And one thing I liked already is that you mentioned you will be covering some of the examples, practical examples.
yes,
So I think that also will be quite useful
yeah.
for us.
Yeah, I'll do that. Yeah, thank you. Hey, so with that, so I think I just start with a brief thought. So first of all, you guys know very well. So what is electrical protection system? I mean, we know that we have electrical distributions, and in starting from energy generations to the end usage of it. So in that process, we need to ensure that we have proper safety, security, and usage of these energy for the mankind. So in that process, you need a lot of safety and protection equipments, and that's what we typically call as electrical protection systems. So so the question that comes is, what happens if I don't have all of these? So any thoughts? I mean, if we don't have electrical protection devices, what will happen? So what are the key hazards that you can see? So yes, so you will have fire accidents, you will have loss of property, you would have human safety, security, and also the assets. So a lot of assets are being powered. So you have to ensure those safety of those. So human assets, all that are the important. So key is basically fire. So we know who generates fire in electrical protection devices, mostly arc, right? So arc is one of the main reason how you get fire. So in this process, I'll be also talking about arc little bit. And but so we know why electrical protection systems as a basic, but the question is why asset performance management? I mean, but why data science or any of these analytics for these kind of products? So you know that this industry is not well versed with all this. Quite recently, people are starting all the global leaders are starting with that. Still, we do a lot of electromechanical devices and all that. So making it full digital or digital integrated, then doing all the collection of data and then doing the protection is quite still long way to go. So the question is, why do we have to do asset performance management? APM, I stand by asset performance management. So why we have to do that? So basic, again, the asset performance management, the basic definition again lies with uh, protecting and protecting the assets that are uh, in use, and then utilizing or optimally utilizing them, and predicting the life of the assets so that we ensure that we have timely replacements or appropriate actions that are taken, and then understanding the phenomena that are happening from these devices so that we take intelligent decisions uh, from the behavior of those systems by understanding the physical phenomena that are happening. So that's these are all of the reasons why you do asset performance management. So just to justify the talk, uh, that's what I just try to say, that why you need a APM for these kind of electrical protection systems. Now, I mentioned that most of these fire accidents happens due to arc. So just look at little bit of arc property. So you guys know very well. So I'm just glancing through. So arc operates somewhere more than 1000 degree, and sometimes even much more than the devices are much bigger. Even it goes to um, much beyond this temperature, tens of thousands also. There are almost 150,000 fires that happens annually only from home electrical home wirings, and then forget add also the industrial firings that happens. That's a huge number. It's nearly 1,000 people die every year, and leading to 6,000 injuries due to arc, and around 1.5 billion property loss or asset loss happens. 1.5 billion is something like one Infosys, right? So something like Infosys, big company. So that much of assets that gets lost in process of all this. So there are a lot of standards that have. So I mean, these are nothing new I'm talking here. So I'm just trying to give some brief of what the discussion is. So lot of these standards of NEC standards, UL standards, IEC standards have come up with for many years, have come up with these their codes which needs to ensure for proper detection and safety of the electrical protection devices, so that it protects your assets which it is powering. So what can be different type of arc? So basically, okay, by the way, I can take some pointer, ledger, okay, ledger pointer. So typically, arc can be a series arc or a parallel arc, right? So this is a series arc. If you guys are seeing the arc here, that is already showing for you. So it's like due to loose connections, right? Or a breakage of a wire. So that's where you see that arc, especially from series. Parallel arc can be basically due to short of hot or neutral. So line and ground. So again, it is of two types: line and ground, line and neutral. So you get this kind of arc. So it's essential that we understand these arc, their physical behavior, and then. So by the way, this is only to explain. I mean, you say why I'm not talking about something else, or why arc. This, like I said, just to justify my discussion about assets performance management, I just picked arc being little hazardous and a key part of the electrical protection device. For that matter, you can take anything else also to discuss. And then I will try to slowly take you through how it is connected to digitally and why you have to do digital and all those things. So in that context, so yeah, so parallel arc can be again two types, uh, and it is due to the short circuit between those. So that's going to be huge. So detecting these appropriately, we have many devices, so it's nothing new. So one of such devices that we use in home, in your load centers are like AFCI, arc fault circuit interrupters, or arc fault detection devices. AFCI is a UL type of device, AFDD is a IEC type of device. And then you have also arc vault for bigger kind of industrial kind of applications. So all these devices are well available. And so typically, if you look at a trip time characteristic curve for a circuit breaker, this is how it looks like. So you see the protection area, the protected area is where we have the circuit breaker performance is this like, the trip time characteristics. Now the AFCI runs in the unprotected area. The way these signals are, that's where it is critical. So understanding arc physics is a big deal, and we have a lot of research on that, and it's getting mature, and certainly we are able to detect nicely. But it's a lot of efforts there as well. So this protects the unprotected area of your trip time curve. Um, Typically, how AFCI is for a residential application looks like, you have your line and the neutral, and this is your device. So you have your sensors that sense that's typical arc current, right? And this is where your load is. So this is how this device is a single pole device, by the way. So this is how a typical arc fault circuit looks like for residential applications. In US, every house need to have a arc fault and a ground fault mandatorily. And house in the sense every room, I mean. It's mandatory to have every room AFC and a GFCI. That's not the case in India, but that's most of the Western countries. That's essential. So let's look into typical arcing phenomena. How do you define arc? So if you just look at voltage, current, and time, so this is basically arc current, the blue one, and the red one is arc voltage. So arc creation, a process of arc or arcing phenomena is because of creation of a gap or temporary dielectric breakdown of the gap, or a restriking after the zero cross. That's in a AC system. So these are the typical ways that how the arc is created. And if that get amplified and reaches to a hazardous level, that's what it creates a lot of hazard. And that's really what I told in my first slide, how it severely impacts. So like, again, so we need to detect these. So we have well-established mechanisms to detect arc. So line to neutral arc generally will be of high magnitude. So, and for a residential applications, the average fault current will be something like 300 amp. This is typically for a 15 ampere FCI or a 20 ampere FCI. This will be a typical current fault current. Then you will have your patterns that you have to find out for arc, and then keep it. And then you have to use that pattern to detect whether it's an arc or not an arc. Parallel arc is little easy to measure compared to series arc. Series arc is a series arc. So that's the ideal. Red one is a ideal current, and blue one is a arc current. Its amplitude and time. So one characteristic is flat solder at zero cross. You see that flat solder at zero cross. Then arcing current RMS is lower than your normal current. And voltage across the arc generally appearing a square wave, and you get high frequency noise components in a series arc. And I think you guys also have communications as a thing, so you know how to measure high currents. So that's one of the way to measure the high current. Sorry, high frequency, right? So you have to do some signal processing to understand your high frequency components. So then frequency corresponds to reignition. So there are some particular frequencies that happens at the reignition. So that you need to detect to find whether it is a series arc or not. So do remember these characteristics, by the way. I said this session is going to be interactive, so I'm going to ask you some questions for sure. So yeah, so this voltage, the same thing continuing. So it's a voltage and a current, arc current and arc voltage. So voltage wave forms of spikes at the restrike. You can see the spikes at the restrike. And also arc is purely resistive. So current and voltage are in phase always. Arc resistance is usually very small value. And I square R losses are only one component of the heat. So the loss is not due to only the heat. I mean, there are many things. So energy is dissipated due to ionization breakdown of the medium. So it gets much more amplified. So it's not only the heat that comes. That's why it is more severe and dangerous. So with this, so do you have any questions for me? What's the arc? And I told you that you need to detect these, and that's how you're able to protect your electrical systems and also the assets that the electrical systems are connected to. So any questions for me? No? Okay. So tell me whether this is an arc or not arc. I'm going to move slide only after I get answer. Questions to you guys. This is a signal arc or not arc? Arc signal or normal? Anyone?
No, sir, it is not an arc.
Okay, so nice. What's your name?
It's Krishna Mohan Sharma.
Oh, great. Okay, this is not arc. So this is a incandescent lamp. Okay. How about this?
Yeah, this one seems with flat shoulders.
So Krishna, so you are only talking. Okay. So according to it is arc. Okay. Anyone else? So many people are there. I didn't see how many people. What is the strength of this class? 20, 30? What is that? How many of you are here? Someone else?
I think the master's program has about below 20 the strength.
Okay, thank you.
Then actually, since we have the recording of this, so eventually everybody, even the UG students also are going to watch this. So that's what.
Okay, okay, nice. Okay, great. So someone else, so Krishna said it is arc. Someone else?
Can I take a guess? Although I'm not a student. So
Okay, sorry.
it's I mean, since it looks like a repetitive pattern, so uh, I'm feeling that it's not arc. So, but I may be wrong. I'm not expert in this area.
No, thank you. So this is not arc, so that's
It may
nice.
not be arc. Yeah.
So this is not arc, so nice. Okay, so how about this? So students, so you see your professor is quite interested in participating. So we expect you guys also to participate. So come up. Arc, not arc. So there is a reason why I'm asking you this. I'll explain you after this. Reason for this small exercise. Anyway, post-lunch session, so I thought of intentionally doing a little bit of this, but also there is a reason. So only Krishna is the speaker, or rather, so the leader for the class. How about Krishna? Arc, not arc? Who else is there? I can also name the people. Let me. How do I escape? Escape. Where do I go? Here. Okay. Well, so many people are here. Okay. Arnav Mandal. Arnav Mandal. Arnav. Okay. I don't know. I feel all are students. So if I ask any faculty, please excuse me.
Yeah.
I think
No, I think all are students. Yeah.
okay, great. Arnav Mandal, what do you think?
Take a guess, anybody? The question is very simple. It's already there on the screen. Is it an arc or is it normal?
Yeah.
It's arc.
Okay, nice.
Harish is saying it's arc.
Okay, so yes, so sorry, went back. Yes, so this is a arc. That's nice. So you know the region. So some of those characteristics I told you. Wonderful. How about this? Okay, let me tell you. So this is normal. This is just a lamp turned on by a knife switch. So if you just turn, I'm sorry, if you turn on your lamp just by a knife switch, look at the patterns you get. So, and also some pattern here. So you should not mislead and say that, okay, it's an arc. So this is just careful observations. How about this? Anyone, any guess?
Maybe arc.
I'm not going. Arc. What's your name?
Harish.
Haris. Haris. Okay, so it's, according to its arc, look, bulb screwed into socket with power on. So if you just take a light bulb and your switch is on and you just try to screw the bulb, this is how you get the signal. You see? Okay, so so the reason I'm trying to tell you, you cannot expect your user to be very careful in everything. You see? So user can do anything, but your device should not do mistake. So the detection device should not do a mistake. That's the important piece of the observation that I want you to understand. Okay. What's this? Anyone? Feel free. I mean, it's okay. It's okay to tell a right or wrong. So there's nothing right and wrong, by the way. Device can also make a mistake. And Rajula Zui. Any guess?
Is it something like a power electronic device?
Yeah. So yeah,
Oh, it's
so this is
arcing.
the arc, and in a power electronics device, yes, you will get this in a loose motor, in a loose wire, you will get this kind of arc. So
I was wondering whether it would be because of switching action of thyristors or something like that. Because
okay, no. Okay, so you're referring that. Okay, no. So so it's a loose wire. You see? Okay. So
I have just one quick question.
yeah,
Again,
please.
the examples that you are showing are at the appliance level, right? But usually when we talk about this arcing and circuit breakers and things like that, that is at either at the distribution HT level or even a higher voltage level. So are you like also working at the appliance level on this detection?
You see, basically, in the current context, I think you're right. So current context, these are all in a residential applications to protect your appliances, protect your assets in a home, be it a residential building or a commercial building, right? So the context which I am talking here is from a building perspective, whether it's a commercial or a residential building. But you are right that there will be arc in your high voltage lines, in your HVMB, and in those lines we have devices called arc vault. So if you just so this little higher version of these, I mean, that have more voltage and current handling capacities, because like the ones that I'm showing you are like in your home you take maximum 30 ampere. So these devices I'm just showing you in a 30 ampere, protecting your appliances and assets in a building perspective, residential or commercial. But if I just little move towards a distribution segment, then you'll have to use something like arc vault. There also similar kind of protections and behaviors, but again that will be of higher capacities. And we have devices called arc vault, which do these heavy industrial protections, and that can take a huge amount of energy and distinguish them. So it's also, by the way, so far I'm only talking about detection characteristics and all that. There is a much beyond physics of, like what I said, arc physics. We have a very big research that happens, be it in G earlier or now in ABB, on arc physics. So how do you quench this arc? Quenching this arc, and I mean, sometimes, arc happened. I mean, you detected, but still it is coming, and something is happening before you act. It is coming. Now you have to quench it. You cannot let your device to burn. So how do you quench it? So that's a big phenomenon. So that's a big physics that we do. So it's a physical model that are developed where we simulate them, compensate them, and then that kind of things are implemented in design so that your product handles that. So that piece also is there. So design of those is also another piece of it, which I'm not touching because my talk is purely on asset performance management and all that. But yeah, that's a big deal. Did I answer your question, Dr. Pradeep? Did I answer, Dr. Pradeep? Okay. Am I audible still? Someone, can you say yes? No, I don't know. It looks like I lost.
Yes, sir, you are audible.
Yes,
Okay.
sir.
Okay, so I was just asking. Okay, so that was the answers to Dr. Pradeep. So he had a point. So this is arc. Now, what is this? Can anyone say?
It is normal.
Mm-hmm. Sure. Okay, so if you take two carbon rods, just do a simple experiment in your lab. Take two carbon rods, both sides you energize them, use a screw gauge or something and try to rotate them, because you cannot touch the carbon, so you'll get the current. So use screw gauge or something to rotate them and closely make them to each other and pass the energy. Then you will get at the, while its joint point, there will be arc, and this will be that arc. You see this and this. Okay, so how about this? Yes, no? Arc, not.
Sir, it seems periodically.
So what is no arc?
Sir,
Okay, good. So this is not an arc. So this is your computer's power supply, right? So that's how, when you power on your subcurrent computer, this is how you get the signal to your computer from your socket. Okay, so wonderful. So now you understand why I was talking about all this. So first point, the reason I talked about this is you see different kind of waveform. I just gave you a handful of 5 or 10, and in that you guys are purely from power electronics, power systems, and you have little difficulty in catching these and all that. Now imagine your device have to do that, which is not having intelligence, right? You are smart guys. The device don't have the smartness. It have to catch that information, say that it's arc or not arc. I'm not saying that today it is not doing. It is very well today doing. But in this digital era, how do you get into that? How do I autonomously decide it's the arc or not arc? And tomorrow, if I have a different signature that all of a sudden my device gets for the first time, how I will ensure that I properly characterize that and make that learning available to all the fellow devices. And only few devices I showed you. So there's like hundreds and thousands of devices. So there's so many different patterns you will get. So just 5 or 6 year old database. This is our database, by the way. Just 6-7 years old database, and you are seeing there are 12 categories, 167 ARC kind of cases, 2 to 11 non-ARC cases, 60 kind of INRAS out of that, 151 normal. This is more than 25 GB of data. Just something 6-7 years old, which when digital was not that boom, at least for this industry. 25 GB of data. Now imagine today it's more than 100 plus GB of data, and it have to be real time. You have to take this data and analyze it, and data is growing, like I said. And these detections you have to do, and you have to do a lot of other digital things for your device. And these decisions have to be done, by the way, as per your standards within 0.5 seconds, right? 8 half cycles you have to decide it's ARC or not ARC. You do not have all the time to do that, right? So that's what is the requirement. Why you have to, so I just told you what is a electrical protection device, what is a key reason why we are using protection devices, because you have to save from arc and its arc hazards like accidents, fire accidents and all that. And I just gave you for a particular electrical protection device for arc, that is AFCI in your home, how complex it is. Now imagine like this, ABB have more than 1 lakh such electrical protection devices that we sell. And now in a electrical protection or infrastructure, we have nothing less than 100 plus variety of devices. All this complexity of each of the devices have to be understood, and then you have to do the asset performance management. And that's what is the need of the hour. That's how you bring the intelligence to the system. And that's what exactly we try to do. So you understood the data amount. So, and that's how I'll try to little bring why digital industrial in a context of ABB. So why digital? I think quite obvious that you know, what is this, by the way? Some heart rate data is monitored. So you guys are wearing your what you call these smartwatch, right? So it try to monitor your heart rates and all that. It takes the data, sends those to your physicians. If there is some abnormality observed, tells you to go to the hospital. So that's the importance. So just an example out of context, but that's the importance of digital. So data is the new oil. So it enables you to create the value through advanced analytics, and that's why you have to understand the data, extract information, so that enables new businesses. Data enables new businesses. So ABB have been always in all the industrial revolutions. So if you look at starting from 1800, somewhere at 1870 or something, till today. So this was like industrial 1.0, that's what mechanized machines, manual work. Starting from these industry 1.0 to till today industry 4.0, ABB is a company that have witnessed all this timeline. We have been there since that 1880 or so till today, and we're quite partnering with all the industrial revolutions, including today's digital industrial, and we're one of the leaders in digital industrial for cyber physical systems for industry 4.0. So yeah, so starting from mechanized machines to motion to computerized machines or robotics to electric vehicles. We are one of the global leader in electric vehicles. To your digital enterprise. So we are also constantly endeavoring to adjust our portfolio so that little bit of business I'm talking here, because I have to bring some context to why digital. So just also it helps you guys understand what what I talk here. So we have been constantly changing our portfolio in ABB to ensure that all our solutions are digitally enabled, and focus is on digital industries. So currently we have divested the power grids to Hitachi around 85%, 88%, and these are the key businesses that we are focused: electrification, industrial automation, motion, robotics, and discrete automations. So I'm part of electrifications business, which is around 12 billion or 13 billion US dollars revenue. It's one of the industry leader in electrical protection systems and devices. So what we do is, starting from in electrification, we do all the low voltage, medium voltage building and infrastructures. We are global number 2 here. Industrial automations is again measurement, analytics, power control, DCS. Motions, motors, generators, drives, smart sensors. Robotizations, again, machine factories, robotics. So we are either global number 1 or number 2, offering all the digital industry solutions.
Dr. Pal, one question from my side.
Please.
This is, from the perspective of careers. So if you see, I mean, your background is not actually in pure electrical engineering. You are from photonics and, various interdisciplinary. And why I'm asking this question is, there is this tendency for students to continue in the same, like if they are in electrical, then only electrical, and, like that. So how easy or how difficult it is to go into this particular careers? Like now you mentioned you are in electrification, but then you're also expertise in data analytics, which is not purely traditional electrical engineering field. So can you throw some light on it as a guide, career guidance for the students?
Okay, thank you. So great question. So yeah. So I think that quietly summarizes to how my biography that you read. So you see, actually, okay. Let me give my in context of my case. I'll give you example. That's how you should read it. My answer. So you see, I did my specialization in optical fiber communication. I joined as a campus interview in a company called Optivo Photonics. I was a research engineer there, doing the R&D work for the optical fiber communication devices. So basically, my customers were BSNL, Airtel, all these your telecom providers, and I was basically my specialization in optical fiber communications. I was doing something called optoelectronics there. So it's a combination of embedded systems and optical communication, optical devices, and all that. So I used to make. I have developed 2 new products there. Very innovative product. Your digital, the smartphone that you are seeing today is just maybe 8-10 years old technology. The OLED or the LCD displays. Somewhere in 2004, 2004. That's the first time we have. Through my program, I was launching the smart organic LED displays for those markets where we are offering a very handheld, compact, smaller than a mobile, a optical measurement device. We will measure, throw the optical energy and then measure the energy. So purely the work was a combination of embedded systems and all this. So there was, with that career progression, I joined GE. For embedded systems, and GE is a very vast company. So, it have a lot of things, starting from healthcare to aviations to electrifications to rail, motor, anything that you name in the globally, everything GE was when I joined. Currently, they have streamlined though, but at the time of 2006 or sometimes I joined GE, it was of that kind. And I was joining because I had embedded systems competency, and so I joined GE. And then the product lines they have put me into is electrifications products. So yes, it was a different field, but I understood the product line and I worked on it, and I have gained the competency that are required for electrification. That's how, like the answering to the question that Dr. Pradeep asked. So that's how I gained the competency in these electrifications, and I have been developing key products for electrifications, doing cost outs. One is developing a new product, another is removing cost from a product. There is some concepts called cost outs, where today if I'm selling a product which is at $20 and I'm making 2 rupees, a $2 margin, say, or what you call profit, there is a need that you to sustain in the market, you have to reduce your operating costs so that you get the product within, let's say, little lower cost, so that your margin, instead of $2 or $3, it becomes $5. So that means I will save $5 or profit $5. So to do that, you cannot just do some supplier change on that. So we have to do key research and innovation. I don't know if I have, someone should count my time. I don't know, but just to quickly sort. So there's some programs I used to do where we bring new innovations to these electrification product lines, where I can make all the specifications that are currently there or better than that, but still reduce the cost of the product, so that I do that point. Particular example I said, that how do I save money. That's so when you do that, that kind of research is more domain domain specific research. It asks you more demand to understand the product and the specifications, compliance to the standards, and then bringing the new technologies that are available to the product and deliver the solutions. So by virtue of that, so certainly, and also new NPIs, I gained that electrifications. And meantime, I did my research, basically my doctorate in data science, especially on mathematical models of complex systems and all that. So by the time I finished, in parallel when I was doing that, when I finished that, it was a perfect combination of electrification, which was just about to start digitization, and then my research work from this have combined, and that have then I just tried to bring that knowledge to electrifications to develop analytics solutions for the electrification product lines, especially asset performance management or uh, autonomous asset life predictions and all those things for the electrification product. So that's how my career is. I don't know if it is by accident or the way I interested and all that. How this change from optical to electrification was basically that. But you see, the key thing is, as an engineer, we have to be with engineering. The domain knowledge, there is no complement, no alternate to domain knowledge. So as a career advice, I would recommend, don't change your domain knowledge. I mean, don't change your engineering. I mean, don't go to all of a sudden, okay, data science, so don't go to be an electrical engineer or that. You can join an industry where your engineering knowledge is used or your science is used. Don't join a bank or don't join somewhere which is not utilized, because your training is not utilized there. So if you really enjoy the work, certainly use that. But your domain knowledge, there is no substitute, obviously, and you have to build over that to uh, bring innovation. And passion is important. Certainly, you have to bring your passion to drive those. So that's how I was for my case.
Yeah, thank you so much for the elaborate answer. Yeah, what I felt was interesting is, probably at the time when you were doing PhD on data science, probably at the time nobody was even looking at this topic. Maybe now today everybody is, irrespective of their field and all, everybody is now this.
Exactly.
So I mean, the ideally, that's how the PhD topic should be. That by the time you finish and then
Yeah,
you get.
it's quite interesting that you brought that. I'll tell you, when 2008, I was initially interested. Okay, I should do a PhD, and then 2009, I started understanding what should be my problem and all that. I was working, so it have to be external PhD, and I thought, okay, so I should do something which is computational, because pure experimental will not lead to the time and all that. So, and then when I started looking into that, then I thought of doing these complex system analysis using all these data driven analysis and all that, parametric, non-parametric analysis. So then when I was sometimes in 2014, I realized that okay, my PhD knowledge is of no use. I'm saying, okay, how do I use this knowledge to this field? I remember I used to give some proposals to my company, and they say, okay, but this is good for healthcare. Why don't you propose there? We don't need. I used to not get appreciations from leadership, but I didn't lose the hope. I think that's one of the point I always say. Don't lose the hope. So somewhere in 2015-16, when all my concepts, proposals that I was putting were accepted, because at the time when they felt that, yes, I think we need to have those analysis of data for these electrification products. So that's how it works. Maybe a miracle for in my case, but that's how it. But everything will not be miracle. Sometimes you have to plan your career also, but don't lose your domain knowledge or engineering too, because there are a lot of hope. There are a lot of challenges industry is facing, or the in the academic also. There are a lot of research that you can do to betterment of the human being. So that's where we should all focus. And all R&D is all about that. So your passion matters most. Okay, so I will, for the sake of time, I'm just little going to count the time because I have a lot of things to cover. So can I proceed, Dr. Pradeep?
Yes, sure,
Yes.
Dr. Paul. I think maybe you can take 10-15 more minutes and maybe final round of question and answers, and we will try to wind up there. We also
Okay.
don't want to take more of your time. That's the reason
I,
why we
I'm
kept it.
I'm not even half of my presentation, but I'll rush through. Really, now I'll rush through. So please
Sure.
excuse me. So because I don't know, something come and I was talking so many things in a single slide. Okay. So what
No,
I said is,
in fact, that's quite interesting. I mean, one of the purpose behind this kind of sessions was also that not only to explore the subject, but more in terms of career planning and things like that. So,
yes, yeah, I think that helps really. So this motivates the students. I agree with you absolutely. So yeah, so you see, in this current slide, I was telling you we have been focusing purely on digital industries because I told you why we are focusing, and or for that matter, why some other industries should focus on that. And either we are global number one, number two in these market segments, and but not only that, money also matters. 410 billion industry. That's a big money. We are only less than 10% of it currently. We are around today 34 billion. So let's take 10% or 8-9% of that market. If you just be 10%, you will be like a 41 billion. That's like little close to Reliance Industries. That's a big money. So that's why people are focusing on digital industrial. So if you guys are thinking of startups, innovations, you can always think on these terms because data is new. I'll think something based on data. And this, is it going to saturate? No, that's what everyone says that's the future, because this 410 billion is going to grow to 510 billion. Annually, it is growing by 3.5 to 4%. 3.5 to 4% is a very big growth. That's a very, very big growth. And if you just look at how these dollar that you are seeing, how it is distributed to different industries. Look, software, digital solutions, 8%. Robotics, flexibility manufacturing, data centers, machines and factory automation. That's where you guys fall, 5%. Renewables, also you guys think 5%, 5+%. Food and beverage, maybe you are not, but 4 and 5%. Commercial buildings, we are all very well into that. Commercial and residential buildings, smart buildings, 4 to 5%. Residential buildings, 4%. oil and gas, motions. So it's a big opportunity. That's why every company is focusing on that. By the way, this graph tells you what is the level of digitization that have happened in this industry. Or not in this, I mean, overall, in all the type of industries, what is the level of digitization? If you look at information communication technology, the last one, this is where the most highest level of digitization happens. It's almost like a saturation. Media, somewhere here. Consumer finance, big here. Retail, somewhere here. You know, we guys are somewhere here. We guys are somewhere here. All our electrifications, all that. So information communication, the optical fiber, whatever that I was specifying, those are all somewhere here. So good that I was in electrification, so I have now opportunity for growth. When a company is growing, you are also growing. That's how you are. So look, chemical, oil and gas, automotive, utilities. Utilities is not about your electrification only, utilities. That's how these are. So there's a huge growth in terms of digitization. That's how you should focus on. Okay, so that's a key topic. Why the so autonomous asset management or asset management. So I told you why electrifications needs to be focused, how it saves energy, why it's a need of asset performance management, why you should do digital industries. Now I'll tell you what I mean by autonomous asset. So you guys know what's asset management, asset performance management. I explained you a little bit concepts I'll try to give you from here. You know, it starts from the basic concept of statistics. Data science is nothing but purely statistics and mathematics, addition with computer science. Okay, so data science is ultimately about that. So it's a pure statistics with required mathematics, and then use of that in computer is your computer science algorithms, programs. It's all about that, nothing beyond that. But alone data science is nothing. Your domain knowledge is essential along with data science to extract information. So do not undermine your domain knowledge. Your domain knowledge that you are currently gaining with data science will be like a boomer, will be like a big game changer. But alone electrification or alone data science is just nothing. Alone data science, you can go to Amazon or Flipkart and try to develop their apps, because they're purely that. But we are not selling toothbrush. You are selling electrification products. You have to bring innovation here. This data is different than your Amazon data. These data have a lot of other physical system information that have to be driven with physical analytics. You cannot do just like that normal analytics to drive the information. That's how the criticality of these systems are. So your domain knowledge is not a substitute. It's most essential, and with data analytics brings the difference. So with that, what is your autonomous asset management concept? So it starts with basic principle of statistics. So I just give a reliability graph. So you know, this is time. I'm assuming you guys are aware of it, and for the time matters also, I'm little going fast. So this is time. This is your reliability curve, and this is how your reliability R of T will look like if you plot against time. So this in term tells you the survival function. Survival function is nothing but how much remaining useful life you can calculate, because how much more it can survive. That talks about remaining useful life or health of the device. So I'm just trying to give you a very basic concept of how, and the reliability is pure statistics that you guys know. That's how statistics is playing. That's how the analytics is playing. When I'm talking of life, that's how I mean that you have to calculate the life. No, it starts from here. Then for the parametric, non-parametric, your machine learning, other things will come top and above it. So look, I think you guys know about this bathtub curve, right? So DFR is your decrease failure rate, your corrective or constant failure rate, your increase failure rate. This is where your basically end of life starts. So knowing this well to predict your device is very essential. So these are some of the basic concepts of ear edge, but still are what the core of your predictive analytics for healthcare, for life prediction or remaining useful life calculations and all that. So you see, the end of life, you see, that's what so you repair and replace. This is basically like from reactive to preemptive. So after you fail, you go and say, okay, my device is failed, please replace it. But if I can tell when my device is going to fail, then I can certainly plan for it. But if today with data, if I can tell how I will use my assets so that it will not fail, instead of failing in another 5 days, it will fail in another 20 days. Then I can better utilize it. If it tells you, okay, use the motor 5 times a day, don't suddenly switch on the motor, do this and suddenly, if I give you a prescription, how your doctor gives, what your doctor do if you have a health problem? You go to the doctor and doctor says, okay, don't do this, do like this. That means he's trying to prescribe something so that it doesn't happen. And that's exactly if I can do for my assets. And that's what is your autonomous. If I can able to prescribe, if I can move from the condition-based maintenance, from predictive maintenance to prescriptive maintenance, and that is nothing but autonomous asset. So the word autonomous I intentionally put here is basically I am to prescribe. I have to prescribe at the point where I say, how do I change? Instead of, I know that device will fail in 10 days based on this condition. Now if I'm able to prescribe, do like this so that the device will fail in 20 days. By that time, you can have your spare parts ready, bring your service guy and repair it and make zero maintenance cost. And that's what is essential here, you see. So yeah, so something that I'm explaining here. So from corrective to how do is to preventive to then predictive, then to prescriptive. So little quickly I'm jumping, which are not essential. Yeah, so that's exactly what I say here. So monitoring, diagnose, prognosis, prescribe. So you see these are data. So you should monitor, detect. Is there a anomaly or fault? You just find out. Here you say what is the fault. That's how you diagnose. Here what you say, okay, if I will have a fault, how much time will it take to fail the device? Here here I say, how can the lifetime be extended? That means you are prescribing. So that's exactly your autonomous is coming into play. Some chart from ABB Asset Health Center perspective. Like I said, all are context of ABB only. So from descriptive to diagnostics to predictive to prescriptive, and this is where your autonomous, this is where your action comes. And if this action happens, that means you are thinking like a human. If you're able to prescribe, you are thinking like a human. That's where autonomous comes. That's where you are bringing intuition to the device. That's where you are bringing the intuitive intelligence to these devices. And we are trying to work on this to bring that intuition to these devices. So yeah, so this how the customer values. So today, so if you are somewhere in connectivity, visibility, what is happening in the device, if you are seeing, then you are in the beginner stage. But if you are trying to understand why this is happening, you're trying to understand, then you are somewhere in intermediate. If you are saying what will be happening so that you can predict and prepare, then that is your advance. But if you are able to tell how do I adapt to it, how can an autonomous reaction take place, how can I prescribe something so that it can be extended, that's where adaptability is coming. That is nothing but your asset performance 4.0. Today people haven't reached here, so that's where the whole of the focus is lying to bring here the systems. That's where your explainable AI and advanced analytics is coming to bring here. But you need to have your domain device knowledge to bring and reach here. I think I was somewhere mentioning the value engineering cost out. That's critically somewhere lies here. So all these little bit of skipping so that for sake of time. So yeah, so this I think already I covered. Connect, condition monitoring, predictive maintenance, asset. So your autonomous is lying at somewhere APM 4.0, one step ahead of APM. So what are the basic things for a autonomous asset? Is collect data, predict, inform, and act. Act is nothing but prescribe, automate, and perform. That's exactly what you said. You see, this exactly. So before AI and all that, we were doing like this. Now with the cloud technology, we are doing this, and this is what we are slowly shifting to. You have to act. Act is nothing but prescription. Taking the medicines. When to take the medicines so that that particular problem in your health doesn't happen. Right? That's why you bring intuitive intelligence to the device. There's a 5C architecture for a industrial AI. It's a connection, conversion, cyber, cognition, and configuration. So we play in all these areas. So because cyber is also important, you cannot let your data be hacked. Cyber security is a key part of it. Then analytics, then operation technology. How do you ensure your customer is having the data in a fingertip, not too complex, right? And the visibility, information, all that are properly visible. So that's the important piece of it. So what and how? Yes, so scalability. How do you disrupt your knowledge? Customer solution, how you enhance your customer relationships, ensure you get your product sell. Process knowledge, that's how you develop your algorithms. This exactly I say, domain knowledge. That's what you will able to tell what is the root cause. How do you solve it? And there is no alternate to this. So that's why I also told you in the earlier. That's why I put a mark here. There is no substitute to your domain knowledge. Alone data science doesn't work. You see, little bit of flowchart. If you look at big data with algorithms, which computations power will be your AI. And if I am able to bring a human-like behavior in AI, then that's what you can bring little intuitive intelligence, creativeness to your device, and then it will become a human. So that you can do those of these little bit of autonomous things or the intuitive intelligence that you are talking. And this what is the outcome of a autonomous asset. It becomes little human, not like a human, certainly, because human have a lot of creativity and only God can create that. But we are trying to see how close we can through the data and all that, so that the device become a human. Somewhere reach here. But the processing power of your computation is also important. Data models based on physics awareness of the system and domain expertise is also important. Then understanding the data, developing and processing it is also important to sit into that human, grow to that human. Yeah, so okay, little bit of that. So what is the future from this human? The future of human is human, which is this one I'm talking, is 5G. You know, 4G is going, 5G is coming. 5G is all about data, right? So when 5G is all about data, then these algorithms cannot be any more classical algorithms. Your machine learning no more can be a classical machine learning, which you are currently using. It have to be quantum-based machine learning. And that's all, because the amount of data you will be, this is where the future is going. People have started working on quantum machine learning. Your Amazon is working, your Microsoft is working, your IBM is working. And your computational power also have to be quantum computing. Then only you can handle the 5G and that kind of data to still sustain this digital pace and reach to that human for these electrical systems, or for that matter, also autonomous asset for any of the asset performance devices. And cyber security and physical cyber systems have to be also quantum compliance. This is where the future is. I mean, I'm not saying today, but that's where the future. So you have to also comply to that, to reach to that and sustain that autonomous in the future also. So a little bit of skip. Okay, so case study. Dr. Pradeep, do we have time? Little bit for maybe 5 minutes. I think or.
Sure, Dr. Paul.
Okay, so thank you. So case study. I'll try to show you exactly what we do in ABB. So for electrical, both your power electronics, power systems, we have these circuit breakers, which are a power electronics power system devices. It have internally power electronics circuits, and then your contactors have power electronics and all that. So these devices, we are currently performing asset performance management, and we are trying to now reach towards autonomous asset. So towards prescription, towards the intuitions, towards the human. So we are not yet there for sure. So we have a long way to go. So this is look at how these architectures are. So all our devices are connected, and then we have a cloud platform called Ability, and where we data is collected. We also have edge computations devices where in the edge itself, without cloud also, you can run your analytics. And some of these are snapshots of our existing circuit breaker analysis. So we do health indicators, self-status, then probability of failure, life, maintenance, when your next maintenance. We do the predictive and analytics. Next will be how we'll reach to prescriptive, is what we are currently into. So this is that's a circuit breaker. This I'm now telling about a switch gear. So you see that switch gear have variety of components. You have again a motor control centers, your circuit breaker, power meter, a lot of things are soft starters, frequency converters. All these in a switch gear. We have low voltage, medium voltage switch gears. High voltage unit we have sold to Hitachi, like I said. But with that low voltage, medium voltage, still we do a lot of analytics with that, and we predict. And also we are in these kind of devices. Also we have some prescription to some extent, not fully. Some prescriptions also we are doing. We are slowly starting into that. So this is how a digital. So you can be doing in the edge, or you can do the cloud through ABB Ability. That's a platform we have, digital platform, common digital platform, where we are having all our analytics. So that's about circuit breaker switch gears. Also, I'll give you one example of in industrial automations, how do we do the same autonomous asset is take any of these industries, oil and gas, chemical refineries, power generation, water, pulp and paper, materials processing industries, marine, data centers, food and beverages, any of these industries. We have a system, something like this is developed. This is the architecture of that system, which is basically a analytics suite, which is an enterprise analytics suite that can do everything in a single place. So starting from integration, conservation of data to data lake for developing the information module, then doing the analytics to run the machine learning algorithms for prediction, prescription, then 3D twin, which we call digital twin of that system. I'll show you in a subsequent slide. And we do what asset integrity, asset performance management. Some of the snapshot of that system, if you see here, this is how that software looks like. Remotely from Dubai, anywhere, you can connect and see what's happening in your field from this. So typically there are 5 different oil industry borewells where all the motors are there. You are trying to see which motor is impacting, what is the cost impact of that motor to the business. If that motor shuts down, how much money that company is losing, which part is failing, and why that part is failing, and how much time it will take to replace. All that happens through this. Look at here. These are variety of motors in the bore which are pumping oil, and the red ones are the ones which are not working to the capacity or are failed. And what is the cost impact of them? Everything you can understand. Then in this particular failed units, which part is failing? What are the parameters and which parameter is not performing well, and why they are not performing well? That's your prescription. That's your autonomous. So yeah, this is about that system. I'm just quickly glancing through. And you can do all the analytics models to see what are the actual predicted and why it is failing. Then how can you enhance the lifetime or replace, when should you replace? That kind of information it gives in a fingertip to your customer so that it enhances the productivity of your customer. So what is the future scope and engagement? Yeah, so I think I already talked, somewhere we are here, we have to reach here so that you can sustain that human. Also, I told you that quantum is the way forward with considering the amount of data and computations that are demanding to sustain that human further after you reach here. Once you reach human tomorrow, then day after tomorrow, you to sustain that human and autonomous operations, you have to do that quantum piece to still sustain that. And that's exactly the same thing that I tell here. So is that everything data? Like I said, so no, everything is not data. So then power electronics guys will say, what I should do then? So look, everything is not about only working on autonomous asset to develop the data and all that. So also the device. So look, today we have this kind of MCCBs, but the future is not, should not end here. So everything have not be should not be electromechanical. If everything will be electromechanical, how do I reach to the autonomous? How do I bring into intelligence? So you have to, your power electronics have to work towards making the whole of these products to digital. So ABB is also working on that, on the core domain, where we develop products which are fully digital. Look at this. This is a product we launched in 2019, starting. And this is a fully digital or solid state circuit breaker. And we have our indigenous concept of development of this device based on something called IGCT. So you can read a little bit about this in Google. And this is the product that we are launching. It's a fully digital. Now, if I have this device versus this, I can do better autonomous, better intuitive intelligence, all that I can do better here, certainly, because it is an electromechanical device. A lot of parts are electrical here, except the tripunate and the relay, right? So that's the future, and ABB is in that very well. So we are already launched this fully digital circuit breaker, the solid state circuit breaker up to 2000 amperes. So with this, I just somehow managed to complete. So ABB is a hidden digital champion. So I told you how all different fields we have been working to sustain that digital industries while we are in electrifications. So with that, I thank you for listening to me.
So thank you, Dr. Pal. So yeah, so let's take a few questions from the students.
Oh, sure.
Good afternoon, sir. Vipul here.
Yes,
Sir,
Vipul.
Sir, in the earlier slides, where we have seen that a pattern is required to classify any arc. So my question is, how do we feed such a large chunk of data for pattern identification on a real-time basis? Because it might fail, or it may create a problem if the pattern is not identified there, right, sir?
Very
So
good. I liked.
Incidentally, our student Vipul, who raised the question, also has a background in data science. So I think from that perspective, he might
Okay.
have.
Hey, thank you
And
so much.
yeah,
Sorry, please. I interrupted you. Please go ahead.
Yeah, so my question was also similar. I was thinking so many examples you had shown us. So are these examples also now being analyzed by AI and ML to detect whether it is an arc or not?
Yes. So look, I think if I understand correctly, Bipul, right? So Bipul, so if I understand you correctly, and also what you are referring, Dr. Pradeep, is about this slide. So, and also previously I showed you a lot of those signals and all that. So first is, I told you that the pattern recognition. So you cannot certainly do all of this real time without having some patterns stored in your device. So there is a patented concept by ABB GE, because you know that that GE's that electrification business have been acquired by ABB. So now it is ABB plus GE, whatever. So there is a patented concept for this where we do some kind of pattern recognitions by doing the time frequency analysis. So what we have done is a variety of patterns that we have chosen, and we have done the time frequency analysis like wavelet analysis, we have done first Fourier transforms and other variety of complex algorithms indigenously developed to find out those coefficients and store them so that initially, look at ML or AI, you need some kind of historical information always, right? I mean, how a data science problem you solve. So you have a historical information, you understand from that, then you predict based on that, and if new information comes, accordingly you classify and put it. That's how you do. Same thing we also do here. So we do a lot of signal processing there. Uh, Using the wavelet first Fourier transform, a lot of signal processing work also happens here to analyze those signals and then store them in a historical database in the device itself in some form of coefficients, so that we do a comparison of those coefficients with the existing signal to decide how it is for a local decision making. Then you bring that to a global decision making with analytics. So that's how we today solve it. So is that optimal today? The answer is certainly no. But do we have scope of improvements? Yes, we have. So that's where we are currently also working. How do we improve on that? So recently, I have filed a disclosure. A patent is upcoming for that kind of things. How do I decide about a nuisance strip in using this data analytics framework for these kind of arc that are happening? So we are also working on to improve over that, but currently that's how today we solve. I hope I answered your question.
Yeah.
Dr. Pal, just I have one follow-up question on this. So, a lot of training of, you mentioned about, training of a neural network, through this data. So data itself is a resource, and then after you train it, the weights, whatever you are having in that neural network, will also kind of a something, that is a resource. So when we go for patenting, I'm just asking because I'm ignorant about this, that if the weights themselves be up for patenting, or what is the,
Okay, so
because the training itself, the weights capture the knowledge, right? So can that be patented, or what is it like?
okay,
How will it?
so basically your question is how do we patent in this kind of area? I think if I summarize it that way, so I think your concept is how do we patent in this domain? You have huge scope of patent. Just starting from lockdown till today, I have disclosed 5 patents. Of that, we have 2 granted. So, and only on these electrifications and data science. Just to answer that. Now, I think the basic question is you are not basically trying to you see, if you are saying algorithm weight as a knowledge to a patent, that is certainly not patent. Patent is how do I solve a problem? I mean, if your approach is, if it's to solve a particular problem, for example, I told you, how do I manage the nuisance strip? So today, you know what is a nuisance strip? So something which is unwanted, as simple as that, as the name suggests. So if something, a nuisance happens in my electrification device, that's something little irritating to me if it happens frequently. Let me give you an example. I think we are talking of AFCI. If I remember, one of my program I was doing in 2009 to 2010, I was the global program manager for that. We launched a product of this AFCI, one variant of AFCI, where I have done a value engineering to do a whole new change in the device and launched it. And we are performing quite well. All of a sudden, I got a call, a mail from my counterpart that, look, we have acquired a new order, and customer have asked me to install this product, and we install this. But as soon as they put one particular, in US, if you know that our lights are not having dimmer, like your fan have a dimmer here, but lights, we don't vary the intensity much in India. It's a fixed light, but in US they have a varying light intensity, so that is a dimmer. So with that particular device, if you put another lighting sets, there is no problem. But this particular company, is named Lutron. I remember that today. So if you put that, our device is doing a nuisance trip, and it's a very nonsense to the customer. I said, is it working everywhere with other competitors? He said, no, all competitors are failing. So all competitors are failing miserably. We are sometimes passing, sometimes failing. So that's why we are little better than us, everyone. So that's why they're asking us to solve it. We solved that problem by doing some experimentation in the lab and improving. But that time we were not thinking of data science. But today, now look, what I'm talking today is you can solve this problem in data science. And that's exactly the patent. That how do I manage a nuisance strip decision in electrical protection, which is causing the nuisance to the customer. But I should not also allow a real trip to happen. That also is, you cannot let a real trip to consider the nuisance and spoil whole of your assets. So that's what is a data science problem. If you are able to using data science solve that particular problem statement, that is a patent. That's how the patent have to be approached, not as a weights of a neural network and how the models, what components of a model. Certainly not that way. Is how I answer. But certainly there could be some scope in that which maybe I have not explored. But to answer your question, I am thinking something like this now.
Thank you. So yeah, any further questions from students?
Sir, I have one question.
Yeah, go ahead. Little loudly, please.
Yes, sir. Sir, am I audible now?
Yeah. Your name?
Vipul here, sir.
Vipul.
Yes, sir. Sir, what kind of networks do we use in pattern recognition? For example, is it Hamming network or MaxNet, or what kind of networks can we use for pattern identification?
Okay, so here, certainly when I said about pattern recognitions, here I was purely mentioning about the signal patterns. So, and here we are not using certainly a network problem here, right? So, but if you are just looking at a generic for a electrical protection systems, yes, based on the problem statements, but yeah, generally Hamming is preferred, but it's based on the again the problem statement. It's not a generic one, right?
Mm-hmm.
That's how. Yeah.
Okay, sir. Yeah. Thank you, sir.
Yeah. So please go ahead. We'll just take one or two more questions. Final.
Sure.
Yeah, I think if there are no further questions, then we will end the session. Is that all right, Dr. Pal?
Yeah, I'm sure.
So thank you so much for giving this wonderful, enlightening session. And I definitely enjoyed the initial part where you are quizzing the students for showing different waveforms and identifying whether it is an arc or not. That was certainly interesting. and then the later part also, and your personal experience, how you had like planned or executed your career and all. I think these are all very interesting lessons that we pick up from this. So and again, the announcement for the students that the same speaker will be speaking day after tomorrow on microgrid. So that will also be interesting session we are looking forward to. So with this, I thank today's speaker, Dr. Paul.
Thank you so much. Thanks for listening to me. Appreciate it.
Thank you.
Thank you.